Hey guys, welcome back to our Rust series. So far, we have covered Rust installation, variables, and data types. Today, we are moving into the heart of programming logic, which are functions and control flow. This is where your code starts making decisions and doing interesting things. So, our today's agenda includes function syntax and parameters, return values and expressions. Next, the if and else condition, followed by the match expressions, which are exclusively used for pattern matching. And lastly, we will cover the loops, for example, loop keyword, while, and for, etc. The match expression is exclusive for Rust. It provides incredible pattern matching capabilities, and this is not available in any other languages. Similar construct is available in C++ and other similar languages in the form of switch and case constructs. So now let's start with the fundamentals of functions. Functions are always declared with the fn keyword. For example, in case of the main functions, the main is the name of the function and fn is the keyword which informs the Rust compiler that here comes the declaration of the function. However, note that the main function is a special function and it is always the entry point of your program. Other functions can be defined anywhere in the file and it all of them holds the lower priority than that of the main function. So to define a custom function, type the fn keyword, then type any function name, for example, greet, and here type, for example, println hello Alice. So this is the definition of the greet function. Functions also accept some parameters. For example, with the parameter constructor function, you have to go like this: fn greet user name colon ampersand str age I32, then println hello curly braces you are years old, name, age. So here the two parameters that we have passed to the greet user are the name and age, and the name parameter type is the string, and the parameter type of the age parameter is 32-bit integer. Note that the parameters require the type annotations in the Rust and it is mandatory as well. Whenever you have to define the parameters, you have to mandatorily specify the types of them as well. So this completes the parametric form of function here. Let's now check this by compiling this code. So inside the main function, call the greet user and pass the two parameters. Since first one is the string format parameter, so pass the string a type of parameter. Second parameter is the type of the 32-bit integer. So pass the integer parameter here, for example 32. Now let me compile it. Rest c function dot rs. So it is compiled now. The .pdb and .exe files executed. Let's execute the function .exe. So here I got the string that hello Alice, you are 32 years old, which is the same as this println function parameter. Suppose if you need a function which can return a value as well. For example, you define something like let area is equal to calculate area, and you provide in them the length and breadth. In that case, you have to specify a return value type for the calculate area function whenever you define it. So now let's discuss with that how to define a function which can return a value as well. So to complete this example scenario, let's now define it. Fn calculate area inside the parameter length I32, breadth I32, and now for the type of the return value you have to do this uh, here after the hyphen and the arrow sign, type the I32. So in this case, the calculate the value the which is returned by the calculate area should be of the type 32-bit integer. If the return value is of the type other than the I32, you will fall into the error. Now let's complete this function. So type return length into breadth. So this completes the calculate area function. Now this let's give a values here. For example, 10 and 20. And if you like to print here to verify this, type area is equal to area. Let me save it and run it. Rest c function dot rs, then function dot exe. Area is 200, which is the same as the product of 10 and 20. Hence the calculate area worked fine. Note that to return a value in this function, we explicitly used the return keyword, but you can also return it via an alternative way, and that way is just type the expression of length into breadth, and that's it. So whenever this function compiles, it automatically will return this value of this expression. Such style of programming where we do not explicitly specify a return keyword to return the value of a function. Instead, we only write an expression at the end of the function, and we want it to be implicitly to be resolved and to be returned. Such a style of programming is called as expression-oriented programming. Expression-oriented programming. So this completes our function study here. Now, after this, we will go on to the if and else condition. For that, let me create a new file for the if else programming. A new file if else dot rs. All right, define the main function. Suppose we define a variable number which holds the value 7, and we define a basic if else condition. So if number less than 5, open braces, print ln condition is true, otherwise else condition is false. Condition is false. So this is just a basic if else construct which will check if the value in the number variable is less than 5 or not. If it is less than 5, then condition is true will be printed in the terminal. Otherwise, the condition is false will be printed. So if else syntax goes like this. You first have to write if keyword, then type your condition that firstly the variable name, then an operator to check the relationship, and then the second operand should be any expression or a value with which you want to compare the first operand. Then inside the braces, you have to write the entire logic which you want to be executed under this condition. Similarly, for the else condition as well. In case you have multiple conditions to the check your logic and to execute the multiple expressions, then you have to go like this: if else if, and then another else if ladder, and lastly you will type the else construct and write some logic here. So a chain is formed like if else here. So with this way you can check with the multiple conditions to accordingly execute your program. You can also return some values from your if-else expressions as well. For example, let me remove it. If-else. Suppose I type here let result is equal to, and then if number is less than 5, then instead of the println type something as, for example, I type here big number, and in the else type the, oh oops, small number, big number, So when this if-else expression will execute, if number less than 5, then the small number will be stored in this result variable. Otherwise, if number is greater than 5, then this big number value will be stored in this result variable. So from your if else conditions, you can return a value from them and store into a variable. You can do same as well in case of if else if condition. In that case, you have to just write the if else if keyword and then your expression, then again chain your if else if and type some expression here like very large number, etc., which will end onto the else construct, and then that whatever the result, whatever expression resolves will get into stored in this result variable. Afterwards, we will check out the match expression. Match expressions is exclusive to the Rust programming, and it is similar to the switch case constructs like of C++ programming language. So let me create a new file for that, match demo.rs, then function name, let number is equal to 3. For the match expression, you have to specify a match keyword, then your variable with which you want to check some condition, open the braces, and to specify a individual condition, go like this, print ln 1. Similarly, check for the 2 as well. Then for the 3, and lastly, the underscore, default case. So the underscore case is actually specifies the default case that in case none of the conditions is satisfied, then this default case will be executed and whatever expressions you specify there will be resolved and a result will be returned to you. Otherwise, if one of these conditions satisfies, corresponding events and expressions would be resolved and returned to you. You can also return some values from your match expression and store them into a variable. For example, let description is equal to, copy this, match number, and instead of the println, just type the expression and without semicolon. Oops, here is a mistake. Instead of the semicolon, you have to type comma. Otherwise, the compilation error will be occurring. Remove this println, then comma, again comma, fine. So we formed it into a expression based construct here. Now if we print this description, we will get one of these expressions as into the description here. So let me compile this program. Rust C math demo.rs. Okay, got an error here. Missed a semicolon here. Alright, this must resolve now. Yeah, it is compiled. Let's execute this. Match.txt 3 3. First three is from here and second one is the description value. There are more broad way to check the conditions in the match expression. For example, on this number variable, you have to uh, want to be resolved an expression for all the numbers from 4 to 9. For example, that from 4 to 9, you want something to be uh, printed as a small number. So in that case, instead of specifying each of the conditions like we did here from 1 to 3 for the go on from 4 to 9, instead of this, we specify here a range based condition. So here for all the numbers which holds values in the range of 4 to 9, this small number expression will be returned here, and otherwise in case you have to check for the prime conditions, then you can go like this: 2 3 5 7 11 and then prime number. So in that case, number will be checked on these conditions, and if a number holds any of these values, then prime number will be returned. These two offerings from the Rust ensures the better readability in our program. Let's jump onto the loops now. Or let me define a new file for the loops. Let me define a main function first. So for the loop, there is an loop keyword in the Rust with which you can specify a looping expression in your Rust program. To give you an example, let me define a variable first. Here I defined a mutable a variable named as counter, whose initial value is 0. Then inside the loop, let me increment this counter variable by 1. So for incrementing and storing the updated value in the counter, go like this: plus is equal to, and 1 means that you want to increment the counter variable by 1. Check it by printing it in your terminal. counter and inside this loop to come out of this loop type the if expression that if counter is greater than or is equal to 5 then break. Break keyword ensures that uh, this will come out of the loop and break only breaks the iteration from the immediate loop. And if there is one more loop, for example, and inside this loop is occurring, then break will only break out of this inner loop and outer loop will execute as before as nothing has been happened to it. So inside this loop, counter will be incremented at each iteration and when the counter holds a value greater than or is equal to 5, then break executes and this loop will ends and the commands written after the loops will be executed. So this is how the loop construct works in the Rust. You can also return some values from the iteration inside the loop. For example, let result is equal to loop counter plus is equal to 1 and if counter equal to 10. Oops, there should be no parenthesis here. Break and after the break, type the expression which you want to be resolved and returned into the result variable. So type complete the expression here, counter multiplied by 2. So whenever this if condition executes, whatever value since this loop breaks at counter is equal to 10. So after the break, this expression will be written since counter holds the value 10 into the result variable. The 10 into 2 expression will be stored, which is actually is equal to value 20. So this is how the return values from the loop works. You can check it by printing it as well. Result, comma, result. So this is the loop construct. Let's check this by executing rust c loops.rs. Unexpected. My bad, I forgot to type a semicolon in this expression. Let's again compile. Finally, it is compiled now. Loops.exe. So I got these counter 1, counter 2, counter 3, counter 4, counter 5. This comes from the first one uh, in the first loop that where we printed each of the counter values and second loop just helped me to print the result variable which we got the value from here. So result is 20 which is correct here So this is the example of the loop using a loop keyword. Other than this, the while loops also exist where you specify a while keyword for the iteration. Let me comment this and show you an example via the while keyword. For the while, you specify the while keyword. So while number not equal to 0. In case of while loops, you specify a terminating condition first after the while specification, and then you start writing your expressions that you want to be executed in each iteration. So as an example, just print these values, values which is stored in the number. Number and decrement the value of variable number by 1, then print something like out of loop now. This will print when the controller comes out of this loop. Similarly, you can do iteration over an array as well. For as an example, firstly define an array 10, 20, 30, 40, 50. Let any t index is equal to 0 and while index less than 5 print ln open braces arr index. So here in each iteration of the while loop, the uh, at an if particular index of the array, the value is printed. For example, in case of index is equal to 0 iteration, the value which is stored at the 0th index will be printed. Similarly, for the index 1, the value at the first index will be printed, and it will go on until the all the values of the array is printed. So this is how the while loop works. Let's check it by executing this. It is compiled now. cls loops.exe. Oh, I forgot to um, here the infinitely the value 10 will be was printing because we didn't come out of the while loop. So to come out of the while loop, ensure that the termination condition is specified, and that would only occur when you increment or decrement the variable. on to which the termination condition is dependent on. So just see loops.rs loops.exe. So yeah, got the 10, 20, 30, 40, 50, and 3, 2, 1 is come out of the via the while loop from the first while loop. So in this sequence of loops tutorial, the last one is the for loops. Let's explore it now. So define an array as before to iterate over an array via the for loop. For that, type for keyword, then type a variable name, then in keyword and the name of the array. Open the braces to specify the expression println element element. So this will print each of the values of the array, and after printing all the values, this for loop will automatically ended because there is no further values in the existing array. You don't have to explicitly specify the terminating condition in this case as we did in the last two loops. Check it by executing this rust loops.rs loops.exe. So got all the values 20, 20, 30, 40, 50, and it worked fine in this case. There are multiple variants to iterate over an array. This was just a first way. Uh, for the further alternatives, you can go like this arr.iter method. So this is the another way to print all the values of the array variable, sorry, array construct in this case. You can also iterate over a range as well via the for loop. For example, for number in 1 to 5, print ln number number. So this for loop iterates over the range whose values are from 1 to 5, and within that each of the number will be scanned and printed it via the println function. If you have to print the values in the range from the reverse fashion, you can modify it a little bit, like for number in this 1 to 5 range, and add it here a reverse method. The .rev method reverse these ranges. Hence, the actual range becomes like 4 to 1. Let's check it by executing them. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 5, it was 5 to 1 actually. So this is how you can iterate over the ranges via the for loop. So each of these loops has their own benefits. The first one, where we specified the iterations via the loop keyword. Here, you should use this when you do not have a termination condition beforehand, but inside this loop construct, you actually uh, execute a third-party program, and that third-party program will be responsible for returning a flag with using which you can come out of this loop. Hence, in that application, you can specify and use this looping technique to loop over, and you must use while loop whenever you have a termination condition beforehand, and in that case, whenever you have to iterate over an array or any data structure which depends on the indexes, you must have thoroughly take care of the various errors and exceptions like index out of bound exception most notoriously. So in that case, the while loop will be beneficial. But remember that you have to be extra cautious of errors and expressions and to properly handle them inside your while loops. But for the iteration over an array or over the ranges, the for loops are the best alternative because here you do not have to be worry about the indexes. The for loop automatically stops iterating over an array when it scans each of the elements, which is not possible in the while. Whenever you iterate over an array or the ranges, you have to explicitly keep a check on the indexed values so that you do not fall onto an on an index which is out of the bounds corresponding to the particular range or an array. So remember that whenever you are iterating over an array or over an range, use the for loop because it is the uh, best among the existing loop techniques, and it will keep you safe from the index out of bound exception. Let's now summarize the best practices corresponding to the learnings we did today. So, first one is that use the match instead of the long if-else chains because it is more readable and safer, and prefer the for loops over the while loops because they are safer and more expressive as well because it is it keeps you safe from the index out of bound errors, and it fits more logically on our uh, cognitive thinking whenever we think about iterating over an array or the range. Use the implicit returns, omit the semicolons for the cleaner return syntaxes for the better readability. Keep your functions small and focused so that you can manage all or your defined functions, and also you can relate it to the single responsibility principle for your better code base management, and try to uh, use the pattern matching as best as possible in your code. This is the Rust's strongest features, and with the pattern matching, you are able to check on the multiple patterns or the conditions onto which you are able to resolve a particular expression. And lastly, handle all cases in your match expression. Use the default case smartly so that the conditional branching in your application uh, could be work fine, and your entire application work smoothly logically. So it comes the summary now. Today we covered the function syntaxes, parameters and return values. Then we explored the if-else conditions and the if expressions. Then we learned about the match expressions with pattern matching. And lastly, we explored the loops, into which we explored the three constructs: loop, while, and for loops. I hope this tutorial helped you to write logic and control flow in Rust, and you have grasped the related concepts carefully. In our next video, we will dive into one of the Rust's most unique and important concepts, which are the compound data types, including tuples, arrays, and slices. We will explore that in depth. If you have any questions about functions or control flow, drop them in the comments below. Like and subscribe if you found this helpful, and I will see you in the next video. Thank you so much.